In problem 6, we want to test whether milk consumption in the Midwest is at least 21.6 gallons. At least means greater than or equal to. So the statement shaded in blue is the null hypothesis, greater than or equal to 21.6. So the null hypothesis is the mean is greater than or equal to 21.6. The alternative hypothesis is less than 21.6. Now, this is a sigma unknown problem because the sentence that starts with a sample ends with standard deviation of 6.9 gallons. So that is a sample standard deviation. This is the sample mean, 22.8 gallons, and the sample size is 53. So I'm going to copy 53, x bar of 22.28, and S, the sample standard deviation, into Excel, which I've already done. So the sample mean is 22.28, the sample standard deviation is 6.9, and the sample size is 53. In part A, we need to determine the critical value. The significance is 10%. The critical value is going to be negative. The critical value will be negative because the alternative hypothesis says mu is less than 21.6. The alternative hypothesis is indicating a lower tilde test. So with a significance level of 10%, a one-tailed test, we divide the alpha by 1 because it's a one-tailed test. The degrees of freedom are 53 minus 1, 52. So we find the t critical value, which is negative, in column 0.1 and row 52. So column 0.1 of the t-table and row 52, thus the lower critical value is a negative 1.298. Now we're testing 22.28 against the hypothesized value. The hypothesized value is 21.6. So the point estimate of the difference between the population mean, 22.28, and the hypothesized value, 21.6, is positive 0.68. The sample variance is the square of the sample standard deviation. The variance of the sample mean is smaller than the estimated variance of the variable because the variance of the sample mean is equal to the estimated variance of the variable divided by the sample size. The standard deviation, or standard error, of the mean is the square root of the variance of the sample mean. The value of the test statistic is the ratio of the point estimate of the difference and the standard error. So I'm going to copy these one by one into Cengage now, starting with the test statistic. The test statistic to 4 decimals is 0.7175. The standard error to 4 decimal places is 0.9478. The point estimate of the difference between the population mean and its hypothesized value to 2 decimal places is 0.68. The point estimate of the population mean, which came from our sample of 53, is 22.28. And the critical value, which is a negative value because it's a lower tail test, the critical value was a negative 1.298. To conclude in part G, we have to compare the value of the test statistic to the critical value. And since the alternative hypothesis is mu is less than 21.6, if we have evidence in support of the alternative, the test statistic is less than the critical value. That is not the case. So we cannot reject the null, which means we cannot say the alternative is true. We cannot conclude that milk consumption in Webster City is less than the national average. We check our work and we should get all green check marks, which we do.